Hello viewers, welcome to Big Boy Physics. Today is the second lecture of 3D rotation and today's lecture will be devoted to problem solving, and it is basically on angular impulse and angular momentum. And in this video we'll be looking how omega vector may not be along the direction of L vector. Okay, so let's get started. This question is taken from David Morin. This is a solved example of David Morin. You can check out the book and see some more problems to solve if you want. I'll take few problems from David Morin, Klepner, Kolenko, all those, and some other resources to build up the understanding of you all for 3D rotation. And I know you all will have some curiosity to know more about 3D rotation because of, especially due to the JA Advanced 2020 2016 question. Okay, so let's get started. What the question says is that you have three masses A, B, C of mass m, m, and 2m as shown in the figure. Each of the three masses are connected to each other by three rigid rods, which are inextensible because rigid rods and these are also massless. Okay, so the green lines basically represents rigid massless rods. That is, they are not compressible or extensible. Now, what we do to this system is that we impart an angular impulse at point B. The system is given an angular impulse at point B. You have to tell me the velocities of A, B, and C after the event has taken place, that is, after imparting the angular impulse. What will be the velocity of A, B, C, and the angular momentum of the system? Okay. Now, the impulse imparted has magnitude P. And the system is given that the rod forms a figure such that AC is equals to AB and angle ACB is equals to 90 degree. Basically, ACB is a right angle isosceles triangle with hypotenuse as AB and AC is equals to BC as the, well, here it will be AC equals to BC, and another thing is that angle ACB is 90 degree, and it's mentioned that the length of the hypotenuse, that is AB, is equals to 4a. Now we have to discuss about the velocities of A, B, C respectively, everything. Okay, so let's get started. Can you tell me where is the center of mass of the system? You can find it that the center of mass is at a height A from the base of AB and along the line joining along the altitude of AB from C. That is the midpoint of C and some point, let it be D, with where D is the midpoint of AB. Now, what is L vector? L vector will be basically the R vector of the point of application of impulse, which is B, with respect to center of mass cross P. Okay. Basically, the what will happen is the system will translate along the center of mass line and will rotate with respect to center of mass. Basically, this will have two components of motion. Okay. Now observe one thing. Let us assume that this direction is positive x-axis. The line joining center of mass and C is positive y-axis, and the line perpendicular to the plane and out of the page is the positive z-axis. Okay. So you can obviously deduce the L vector. L vector is r cross p. Now what is the r vector? Suppose this to be origin, the center of mass to be origin. What is r vector of point B? R vector of point B can be given as 2a I cap minus a j cap. So I can write it as 2a I cap minus a j cap cross p. Okay. We know that force is given as r cross f. Similarly, impulse is given as r cross p. You will get it to be, and p vector is along minus k cap direction because it's inside the page. Okay. I marked with a cross sign. So it will come out to be I cross k is minus j. So it will be 2ap j cap, and j cross k is plus I, so plus pa I cap. So I can write it to be pa times of I plus 2j. Equation 1. Now what will happen that it will have some velocity of center of mass, I don't know. Well, sorry, we can know the velocity of center of mass. Velocity of center of mass will be p by total mass of the system which will come out to be p by 4m along the minus k cap direction because it's inward the page. Now, what will be the omega vector? Omega vector, I cannot exactly define my own way. That how we can define, say, for example, if it was a circular disk, we can and we impart an impulse along this positive x-axis, we can say that angular velocity will be along the positive y-axis. Now, in this case, we have to assume a set of angular velocities omega x, omega y, omega z. Can you tell me the inertia tensor? What will be my inertia tensor? Inertia tensor is here is ixx, ixy, iyz, ixz, iyx, iyy, iyz, izx, and all those. So if you observe, you will get ixy is equals to iyz is equals to izx is equals to 0. So basically the non-diagonal elements will come out to be 0. And ixx, if you calculate with respect to center of mass, of course, that is along this line, ixx is given as ma square plus 2m into a square, which will come out to be 4ma square. Iyy is equals to the moment of inertia along this y-axis, which will come out to be 4a square into m into 2, which will come out to be 8ma square. Izz can be calculated by perpendicular axis theorem, which will come out to be 12 ma square, right? So you will get ma square, 4, 8, and 12 cofactors. If you find I into omega matrix, the product of an I matrix into omega matrix, you will get ma square, 4 omega x, 8 omega y, 12 into omega z. And we know that the impulse, this is the angular momentum, the angular impulse is the result of the angular momentum, so I can write it to be ap, I, what is lx, lx will be pa ap or pa, I cap, 2 ap j cap, and 0 k cap. So just here there won't be any diagonal elements, sorry, the product I have written is a little wrong. So it will be 4 omega x, 8 omega y, 12 omega z. Okay, so this will be my result, and I can say that omega x is equals to p by 4ma, omega y is equals to p by 4ma, omega z is equals to 0, just evaluating these two matrices. Okay, so first result we get very easily. This is a very important thing to note. We have found basically the omega vector. I can say that omega vector will be p by 4ma I plus j cap. Okay, so this is my important concept we have to remember, and we know that VCM is equals to minus P by 4m k cap. What will be my velocity of respective masses with respect to the center of mass? Velocity of any point P with respect to center of mass is given as r omega cross r, right? So it will be 4 by P by 4ma I plus j cross r vector of point P with respect to center of mass. Now what is my velocity of point C with respect to center of mass? Which will come out to be P by 4ma I plus j cross a j k cap. I cross j is given as plus k cap, which will come out to be p by 4m plus k cap. So velocity of c will be velocity of c with respect to center of mass plus velocity of center of mass, which will come out to be p by 4m k cap minus p by 4m k cap, which is equal to 0. So this is my first. Then second, vb is equals to velocity of b with respect to center of mass plus velocity of center of mass, and we know that the coordinates of b is given as 2a I cap minus a j cap. So minus p by 4m k cap plus p by 4m a I plus j cross 2a I cap minus j cap. You will get it, I cross j is plus k and j cross by I is minus k. You will get it minus p by m k cap. Hope you understood. So basically velocity of A will point inside the plane of the page, and it will have magnitude of P by M. Now tell me what is the velocity of point A. Velocity of point A will come out to be minus P by 4M k cap plus P by 4M I plus j cross minus 2a I cap minus j cap. I cross j is plus k and j cross I is minus k, which will come out to be 0. So we basically derive the velocity of each of the masses. Now observe one thing, that you could have done it without using the concept of rotation, because we know that thin rigid rods cannot exert shear force. You must know about it, that thin rigid rods can never exert shear force. That is why all the tensile forces will act along this direction. And since there will not be any compression, so there won't be any velocity of b along the direction of the motion, in the direction of the rod. Initially all the velocity will be invested in the perpendicular direction. So basically we will have some velocity which will be p by m. Easily we can easily say that velocity of b will be p by m, because all the forces due to rods will apply in the along the rods, and it cannot have any velocity along the rod at that instant. So it will have velocity perpendicular to the rod. Now A and C will not have any velocity, because tensile force on the rods at that moment should be zero. That is impulsive tensile force, better to say. Otherwise, it may have finite velocity. I'm not denying the fact that it may have tensile force. It may have tensile force due to the acceleration, but there won't be any impulsive in nature, right? Now observe another thing, that A and C are at rest. So can I say that the line joining AC is the instantaneous axis of rotation? This is the IAOR. It is another thing to know. This is the IAOR. So I can find the instantaneous axis rotation, and then evaluating all the other stuff, I get the result also, right? Now the next thing is kinetic energy. What will be kinetic energy? Kinetic energy is summation K is equals to summation dm v square by 2. Integral in this integral form, or summation mi vi square by 2, which will come out to be p square by 2m, because only b possesses some finite velocity. Okay. Now can we use the concept of rotation to derive it? Yeah, of course. We know that kinetic energy is written as kinetic energy with of center of mass plus kinetic energy of body with respect to center of mass. Now the kinetic energy of body with respect to center of mass is given as half times angular momentum with respect to center of mass. Okay, angular momentum of body with respect to center of mass into omega. What is it? Better to say omega matrix into angular momentum of body with respect to center of mass. This is a 1 cross 3 matrix. This is a 3 cross 1 matrix. It will eventually end up with a 1 cross 1 matrix, and the value of the 1 cross 1 matrix, basically we need to take the final determinant to make it a numerical value, and we'll get the kinetic energy of the body with respect to center of mass. Well, it will come out to be half p by 4am 111 into what is L of the body. It's sorry, it will be along the horizontal. It will be a row matrix rather. So it will be 111 into what will be L of body. It is already derived, AP 2AP 0. Multiplying and adding, you will get P by 8am into 3am matrix. Taking the determinant, it will be no m 3ap. You'll get p square by 8m into 3. What is kinetic energy of center of mass? Will be half of total mass of the body raised 4m into velocity of center of mass, that is p by 4m whole square. You'll get p square by 8m. So total kinetic energy k is written as the summation of these two, which will come out to be p square by 2m, and that's the answer. So basically, I have shown how to deal with kinetic energies in this problem also. And if you want to find the absolute kinetic energy, you can use the concept of instantaneous axis of rotation. Well, another thing to observe is that if you see, this instantaneous of axis of rotation is along the I plus T cap direction. Okay. So basically, the angular velocity vector will be along the side AC, right? And to find the velocity, you can also use half I of v with respect to instantaneous axis of rotation into omega square. Then also you'll get the same value. So that's it for today. Hope you enjoyed it. Thank you and have a nice day.